Hello students, today I am going to explain 2nd September 2020 JEE Mains Shift-1 paper. Right, the first question, which metal is used in devising photochemical cell? Here photochemical cell is nothing but photoelectric effect, so which is part of atomic structure topic. Right, so in photoelectric effect what happens, sir? The electrons are ejected from the metal surface when light is strikes on the surface of the metal. So this is happen in photoelectric effect. In this situation, generally we are using potassium, rubidium, and cesium. But among these three, cesium is the least ionization energy from top to bottom. And moreover in this case, lithium, sodium, rubidium and cesium all are belongs to first A group elements. That means group 1 elements, alkali metals, right? Lithium, sodium, potassium, rubidium and cesium. From top to bottom down the group what happens are atomic radius increases. That means ionization energy decreases. So here least ionization energy is cesium. So cesium is ready to lose electrons. That's why cesium has highest electropositive element in this case. You know what? Cesium is in the total periodic table, cesium is the highest electropositive element. So that is also one of the important point here. So that's why cesium is the least ionization energy. That's why cesium is used in photochemical cell. So the fourth option is the correct one for this question. Next coming in the second question. For following cell reaction, copper tin plus 2, Cu plus 2, tin. Here copper plus 2 concentration is equal to tin plus 2 concentration, which are both are in 1m molarity concentration. Find Gibbs energy change in kilojoule. Here we have data also is there. Copper electrode potential is 0.34 volts and tin electrode potential is minus 0.16 volts. So this is our given data. So according to the question here, you need to observe here, copper is converted to Cu plus 2. Here copper is loss of electrons. That's why here loss of electrons are oxidation. And tin is gain 2 electrons. That means gaining of electron is called reduction. So loss of electron oxidation, gaining of electron is called reduction. So and find Gibbs energy change in kilojoules here. So what is our formula? Changing Gibbs energy is equal to minus N into F into E naught cell. So this is our formula, right? But here E naught cell we don't have, sir. Initially we need to find E naught cell. We have number of electrons. Here the total number of electrons, the change in net total number of electrons, how many are 2 electrons? Because copper lose 2 electron and gain tin is gain 2 electron. That's why the total net change electron is only 2. What about Faraday? The Faraday value is 96,500 coulombs. So we have number of electrons and we have Faraday also, but we don't have E naught cell. So that's E naught cell is equal to here oxidation and reduction. Here what are the oxidation value here? E naught Cu slash Cu plus 2. So write down first of all copper electrode Cu slash Cu plus 2 plus E naught tin plus 2 tin. So that is equal to your copper value how much, sir? 0.34. So minus 0.34 plus minus 0.16 because tin value is minus 0.16 here. So works out here minus 0.50 value. After works out here minus 0.50 volts. Now substitute the place of E naught cell. So delta G naught is equal to here minus 2 because number of electrons here, total change net electron is 2 and final value is 96,500 coulombs. So into minus 0.50 volts. Of course here minus get cancelled, sir. 2 into 0.5, 1. So 1 into 96,000. So 96,500 joules only. But we need kilojoules, sir. That's why by 1000, 96.5. So kilojoule. So this is our answer here. 96.5 kilojoule. So next question. Here 5-member ring CH3, CH double bond CH2, CH3 plus. Find out end product here. You know what here? CH3 plus means in this case H plus water. That is the meaning for that. Right? H plus H2O, water here. Okay. And one more in this case CH double bond CH2 is CH2 double bond CH2 is there. So that's why it is Markovnikov. It is a special type of Markovnikov addition reaction, and ring expansion is going to be happen. Right? So these 2 points keep in mind. Ring expansion is going to be happen, and it is special type of Markovnikov addition reaction. Right? So let us I will explain. Let me explain with the mechanism what happened here. Right? So here CH3, CH double bond, CH2 here. First of all, I need to take here H plus and in terms of water, right? So here H plus is electrophile, sir. So immediately when this bond rotate towards this carbon and carbon get negative charge, here carbon get positive charge. Immediately this proton is magnet towards negative. Step CH3 CH double bond CH3. Right? Here I want to give number for this one. 1, 2, 3, 4, 5, 6, 7 and 8. So this is the best number for this one. Here immediately bond here break. So this fifth carbon of this bond is going to be make a bond with sixth carbon. Right? Now here the first carbon here lose of electron. That's why first carbon gets positive charge here. First carbon get positive charge. Right on the next step here. I don't write now something like this. 6 carbon ring. Number 1, 2, 3, 4, 5 and 6. Right? Here sixth carbon having CH3 loop. Write down CH3. Right? Again first carbon having CH3. Write down CH3 here. And I told you already first carbon is lose of electron and sixth carbon is gaining of electron. The bond, the fifth carbon is going to be make a new bond with this CH plus. That's why I mean sixth carbon here. Right? Here positive charge will appear here. And why only here? Because this carbon is surrounded with carbon and again carbon. That's a tertiary carbon. So tertiary carbocation is more stable than secondary carbocation than primary carbocation. So this is the order for that according to Markovnikov rule. Right. So now here in this case we have H2O is there. I told you already H2O here acts as nucleophile. Right. So one of the lone pair is going to be make a bond with this carbon. Right, to form bond CH3, bond H2O structure is bent structure and H2O here lose one pair of electron. So immediately here this bond will break here, this bond rotate towards oxygen and hydrogen get positive charge and is eliminated as a H plus because here H2O H plus is acts as only catalyst, right? So OH over here. Sorry, here CSC is there and CSC over here. Right? So this is the end of the product here. So carbon, OH, again carbon. Right? So carbon, OH, again carbon. So third option is correct for this one. So next question. Structure of Dettol. Of course, Dettol is very well known, which belongs to chemistry in everyday life topic. So generally, Dettol is mainly made up of two compounds. One is parachloro metaxylenol and alpha terpenol. Alpha terpenol. So parachloro metaxylenol. So we know that here OH, here parachloro, this is para direction, CH3 and again CH3. It is meta position and it is also meta position. That's why parachloro, this direction is para, so parachloro metaxylenol. So this is structure for that. So third option is correct answer. So the third one is correct option for this question. And coming to the next question. Which of the following statement about ozone is incorrect? Incorrect. We need to pick up incorrect statement about ozone. First option, ozone acts a product layer against UV radius. Yes, it is correct option. Proton is act as product layer against UV radius, right? And second one, it is toxic layer and converts NO to NO. Yes, it is also correct, sir. Yes, it is a toxic layer, converts NO to NO. So NO when reaction with ozone to form 2 moles of NO2 plus O2. So NO2 to NO2. So that's why second option is also correct. Third option, it converts chlorine free radical of CFC to chlorine dioxide. So what happened when chlorofluorocarbon reacts with ozone? So let me explain what happened here. So chlorofluorocarbons is going to be broken down when by UV radiation to form chlorine free radical. Immediately these chlorine free radical is reaction with ozone to form chlorine monoxide plus O2. These chlorine monoxides are again is reaction with nascent oxygen to form chlorine free radical plus O2 here. So what do you understand in this case? So when chlorofluorocarbons are reaction with ozone, so continuously to releases free radical. But not chlorine dioxide. So that's why third option is wrong option here. Right? And it acts as shield to our atmosphere. Of course, it is right answer. That's why third option is of course wrong, but it is correct for this question. Next question. So this is our compound. We are going to find IPAC name of this compound. So according to IPAC system, first you should bring longest chain for given compound. Here what is our longest chain, sir? Here two functional groups are there, end of the carbons, CHO and COH. So according to priority for functional group rule, carboxylic acid is more priority than aldehyde. So carboxyl group is more priority than aldehyde. So and moreover here carboxylic acid is acts as chain terminating group here. That's why the number starting from here 1, 2, 3, 4, 5, 6. Here double bond is there. According to question, here double bond is there. So 6 is our long chain, and this is one of the substituents here, and here also one of the substituents here. And this is parent chain, right? First of all, write down first substituents here: aldehyde, formyl, methyl, M. So formyl comes first because according to alphabets. So the number of formyl is 5. That's why you can write 5 formyl. And what is the number of methyl here? 2. So 2 methyl. Longest chain is hex. What is the number for the double bond here? 3. Suffix for 3E. And what is the number for functional group here? 1. So suffix for functional group here, carboxylic acid, oic acid, 1 oic acid. Yes, 1 oic acid here. So 5 formyl 2 methyl hex 3 in 1 oic acid, or you can write like this: 5 formyl 2 methyl hex 3 in oic acid. because the functional group is number 1. That's why you can write direct hex 3 in 1-oic acid or 3 in hexanoic acid. So all are correct here. So according to question, second option is correct answer. Right? Second option is correct option. I didn't write here options, but second one is right. And next, go for the second next question. If compound AB4 is polar covalent, then its possible geometry is. Here, two clues are there. Here AB4 is one of the clue, and it is polar covalent. And the second clue is polar covalence is always dipole moment will not equal to 0. That's the best point you need to find here. Yes or no? Dipole moment will not be equal to 0. If it is non-polar, dipole moment will be 0. So, and one more thing in this case, it is AB4 sir. Here how many more atoms are there? 4 atoms are there. But square planar option, we have options square planar, tetrahedral, seesaw structure and square pyramidal. And square pyramidal, that means fourth option is directly eliminated among these. Why sir? Because here square pyramidal. Square pyramidal means 5 mono atoms are required in this case. So this is the possible geometry for this one. Right? So here AB4 is there. Here AB5. That means 1, 2, 3, 4, 5. So this is the formula like this AB5. So that's right. So a fourth option is not correct for this one. So option is only between 1, 2, 3 only. And what about first one, square planar? Sir, square planar, this is the possible geometry for this one. So square planar is always all bond moments are equal. That's why dipole moment will be 0. That's why this is non-polar molecule. This is non-polar molecule. That's why, so first option is also wrong for this one. Tetrahedral, of course tetrahedral we are very well known. So tetrahedral is also dipole moment will be 0 because it is also non-polar molecule. Why sir? So square planar, tetrahedral, all bond moments will be equal. That's why dipole moment will be 0, here also 0. What about seesaw structure? So seesaw structure is, this is the expected seesaw structure here. You know what here? These two bonds are, once again, above the plane and below the plane. These two bonds are not equal to these two bonds. Yes or no? These two bonds are not equal to these two bonds. That's why this is dipole moment will not be. Dipole moment will not be equal to 0. So will not be equal to 0. That means polar molecule. It is polar covalent or polar molecule here. So that's why third option is correct for the question. 3 moles of O2 and 5 moles of argon are present in closed container. Find sum of their internal energy in terms of RT. So we are going to find here sum of their internal energy. So internal energy is not possible to calculate directly. Okay, so according to question we need to find here. So actually the internal energy, determination of internal energy is possible with a warm calorimeter or calorimeter. So calorimeter is always at constant volume. So here 3 moles of O2, that means O2 is a diatomic gas and argon is monatomic gas. So heat capacity at constant value, that means Cv of O2 is equal to, is a diatomic gas, so degrees of freedom is 5/2R. And what about Cv of argon? Here argon is monatomic gas, so heat capacity at constant volume of argon, degrees of freedom is 3/2R. So we need to find sum of their internal energy. That's a right formula here. So delta U is equal to NCV delta T plus NCV delta T here. So here N means number of moles CV plus number of moles CV. So this is for O2 and this is for argon. Here substitute in this case N for here number of moles. Oxygen, how many moles are? 3 moles into CV for oxygen, degrees of freedom 5/2. Delta T I can write 5/2R. So I can write T here plus Next, number of moles here 5. So into 3 by 2 R into T. So next, so 3 into 5. That means that is equals delta U is equal 15 by 2 RT plus again 15 by 2 RT here. So after works out, you will get 15 R2 here. So the option is first one is correct option, 15 RT. Coming into next question. Example of solid soul. Here solid soul is there. Solid soul means you need to remember 2 points here. Dispersed phase is solid, dispersion medium is also solid here. Right? So dispersed phase is also solid, dispersion medium is also solid. So what are the example? Some colored glasses, gemstones. So they all belongs to gemstone only, right? So second option is correct one. What about first one? Butter. So butter is not a solid soul, sir. Why? Because why? Because here butter is dispersed phase is liquid and dispersion medium is solid here, right? Dispersed phase liquid, dispersed medium is solid for that one. Butter. What are paints are? So paint is dispersed phase is solid but dispersion medium is liquid here. What about cakes are? So dispersed phase is liquid and dispersed medium is solid. So that's why here second option is only correct. Question. Graph between log x by m versus log p has slope is equal to and intercept is equal to 0.477. Find x by m of pressure 4 atmosphere. So log 3 value is equal to 0.477. So we are going to find x by m here. So this question is also belongs to surface chemistry, sir. So 2 questions are came from surface chemistry here. In before solid soul, now it is x by m. This question concept belongs to Freundlich adsorption isotherm equation. Freundlich adsorption isotherm equation. So it is very important, sir. Right? So Freundlich adsorption isotherm. What are the equation here? X by m is equal to k into p to the power of 1 by n. Right? So take logarithm on both sides are here. X by m is equal to here log k p to the power of n. So log x by m is equal to here log k into p. That nothing but log k plus log p to the power of n. Log a into b formula. Log k plus log p to the power of n here. So log x by m is equal to log k plus here log p to the power of n, log a to the power of m log a. So that's why here 1 by n log p. So according to straight line curve equation, so y is equal to right mx plus c. So here c is our intercept, m is our slope. Here what is slope as 2, that means m is equal to here 2, that means that is equal to slope here. So that means n is equal to 1 by 2. And what about k, sir? Here k is intercept. What is the intercept value here? So log k is equal to here what is the value, sir? 0.477. 0.477 is equal to log 3. That's why here log 3. So k is equal to here 3. So now to find here x by m. So x by m is equal to k into the power of 1 by n. So x by m is equal to k value how much, sir? 3. And p value, p pressure 4 into 4 to the power of 1 by n value how much, sir? 1 by 2. 1 by 2 here. So x by m is equal to so 3 into 4 square. So that is equal to 3 into 16. So finally x by m is equal to here 48. So option is 48 is the correct option here. So of course I have options are there. First option is 6, second option is 3rd, and third option is 48, and the fourth option is 9. So third option is correct. So according to question, third option is 48. So third option is correct for this one. Next questions. Which of the following graph is incorrect for an ideal gas? Incorrect here, ideal gas. So what is the ideal gas formula here? PV is equal to nRT, right? So N is equal to given weight by gram molecular weight. So PV is equal to given weight by gram molecular weight, because number of moles given weight by gram molecular weight. So PM is equal to W by V into RT. We know the density formula, given weight by volume, W by V density. So PM is equal to here dRT. So here D is equal to, so PM by RT here. So indirectly what you understand here, D is equal to 1 by T. That means D is inversely proportional to the temperature here. So which curve should be expected from this concept here? D inverse proportional 1 by 2 means here hyperbola curve is obtained. Hyperbola curve means this is hyperbola curve here. Yes or no? Right. Yes, this is correct one. First option is correct. And here 1 by T. This is only by T. Denominator is T sir, but here denominator is 1 by T here. So that means D is also here directly proportional to temperature, right? That's why, so the curve is coming through from origin. So second is also right. So here D, here T is there. That means straight line curve is not obtained sir. Only hyperbola curve is obtained. That's why third option is a wrong one. So that's why, so according to the question, third one is wrong one here. Next one, 12th one. Most reactive with HCl out of the following here. Hydrogen cyanide. Here usually hydrogen cyanide is undergoes nucleophilic addition reactions. Right? Here you know what? CHO, 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 CHO. All options are only heads are common. And here NO2 and methoxy. So you should compare first of all nitro group and methoxy group here. So which is more priority here? You know what here? NO2 and methoxy. NO2 is negative inductive effect and as well as negative R effect. And here this is negative inductive effect and plus R effect. So based on this concept here, NO2 is more electron withdrawing group than methoxy. That's why methoxy group is the ultimate eliminated from this one. What is option 2 and option 4 is not suitable for this one. What are the correct option? Only between 1 and 3rd only. Here option 1 nitro group present at ortho position and option 3 nitro group is present at para position. Here NO2 is more negative inductive. That means more steric endurance is possible. That's why, so para position of ortho position of nitro is not suitable for this one. So para position of nitro is correct for this one due to steric endurance and more negative inductive effect. So resonance is also possible, is good for in para position. That's why, so third option is correct for next question. Among the following property, which property trend in magnitude is different from other? So different from other. We need to find, so which property is going to be different remaining other, comparatively remaining other. Here atomic radius, electron affinity or electron gain enthalpy, electron negativity and ionization energy. You know what here? All these properties are depends on atomic radius. When atomic radius increases, all these properties are decreases. When atomic radius decreases, all these properties are increases. So here atomic radius is only different. That's why atomic radius is correct one from across period. Across period means for about group always you have to follow top to bottom. For about period you should always follow left to right. So left to right atomic radius will be decreases. So all these properties are increases. So that's why option 1 is correct one. Next question. Find out correct statement regarding this reaction. So this is our reaction, sir. So product of A, product of A, product of B, product of C here. So we need find. So which option is correct for this one, for this reaction? So first of all, let me explain with an example here. Sorry, let me explain here mechanism for this one. Right, here HBr is excess, sir. HBr is excess. So HBr is going to be destroyed. So this bond and this bond, right? So here H plus and Br minus. H plus is going to be attack oxygen, and Br minus is going to be again attack this carbon, and Br minus is again attack this carbon, and H plus is again attack this carbon, because here HBr is excess. So here 2 moles are required for this reaction. So the next step here, oxygen, hydrogen, that means OH. So bond here break and bond here also destroy here. So that means C here carbon, this carbon Br. That's why you can write Br bond, and this carbon hydrogen, right? Hydrogen, and again carbon, again carbon here, right? This carbon here 1 2 3, 1 2 3, again here carbon, again here carbon, right? So next to this carbon is bromine is there. That's why you can write here you can write bromine, right? So this is A, right? And heated with KOH, yeah, this is delta symbol, sir. Heated with KOH. You know what, this HBr, I want to use one hydrogen here. Again HBr is ignited. So what happens, sir? This bond rotate between these two carbon, and this bond rotate between these two carbon here. So write down the next step here. OH bond, double bond, bond, double bond, bond, carbon. So double bond and again double bond. So this is the B here, right? And the next one O3 with zinc, that means reductive ozonolysis. This is called reductive ozonolysis. What happens are here, when ozonolysis is going to be happen, double bond will break here. This is shortcut method, and write on the next step OH. So here one carbon, that means CHO. One carbon is always aldehyde, and C bond C, that means this bond left side double bond, this bond right side double bond. That means plus CHO and CHO. And last one is, it is look like CH2, sir. CH2 means formaldehyde, right? CH2 means formaldehyde. So this is the product here. This is belongs to C. So let me check whether it is correct or not. Options and answers. Here option A. Option A is a product of A. Here OH, yes OH. Here carbon, carbon, carbon and carbon. You know what, here Br minus, why going to be attack this carbon only? Why not this carbon? Because this carbon is attached to carbon and carbon. Yes or no? And is secondary carbon. Of course, it is not secondary carbon, but this is benzylic carbon. So benzylic carbon is more stable than this one. That's why this Br minus is going to be attack this carbon only. And here why Br minus attack this carbon only? Because this carbon is surrounded with carbon and again carbon, right? So this is secondary carbocation and it is primary carbocation. So secondary carbocation is more stable than primary carbocation. So this is acts as primary carbocation. This is acts as secondary carbocation. That's why here Br minus is going to be attack this carbon. Br minus is going to be attack this carbon only, right? Right. Yes, carbon here carbon, right? Carbon, carbon, Br, again carbon, again carbon, right? Carbon, Br, S, C, and last one is C. That means CH3. What is the end of the carbon is always CH3, right? Here also CH3, but one hydrogen we are used to involve in this reaction. So option A is correct for this one, but let me check next one also. What about B? Whatever product of A is again, so here product of A is not correct for this one. So we got this one. Product of B. So is it right product of B? No. C double bond C and again C double bond C. But here C double bond C, only one double bond is there. That's why C also is not correct here. Here again product of C is CHO2H here. But here CHO aldehyde is there. Right? So that's the product of D also wrong one. Only product of A is correct for this one. Next question. Calculate required number of moles of AC2O in XYZ. Product formation. So these are questions are. So calculate the required number of moles AC2O in XYZ. Here this is X, Y, and Z here. Product formation. When glucose reaction with HNO3 and AC2O. Here how many moles of AC2O is required? The formation product here. When glucose reaction with AC2O, how many moles of AC2O required for product formation? Here when glucose reaction with H2 nickel and second AC2O, how many moles of H2O required for the formation of Z? So finally we need to find how many moles of AC2O required for this question. You know what AC2O means? What is the meaning of AC2O, sir? CH3 C double bond O, C double bond O. So A C taken twice, 2 moles, two times are there. That means O. Acetic anhydride. What's the name here? So acetic anhydride. So usually acetic anhydride is used to measure how many OH groups are present in a particular compound. Take first for glucose structure here. CHO, CH2OH, HOH, OHH, HOH, again HOH here. So how many OH are there in this case? 1, 2, 3, 4 and 5. So 5 moles of AC2O required. Yes or no? 5 moles of AC2O required here. That means glucose reacts with H2O to form, how many moles of H2O required for the formation of byproduct here? 5 moles required. Why? Because we have 5 OH are there. I told you already H2O to use to measure how number of OH groups are present in particular compound here. Here glucose is our particular compound. Here glucose having 5 OH groups are there. That's why 5 moles of AC2O required. That means acetic anhydrides are required here. And coming into coming into X. When glucose reacts with HNO3, you know what here? HNO3 is strong oxidizing agent. That means CHO and CH2OH. CHO is also converted to COH and CH2OH also converted to COH, carboxylic acid, when reaction with HNO3. So COH and COH. So here what are the left OH? 1, 2, 3, 4 only. So how many moles of H2O required here? 4 moles are required. Why? Because I told you already H2O is used to only to measure number of OH. Here how many OH are there? Only 4. That's why 4 moles of H2O is required. When reaction with first one, when glucose reaction with first one. And the next one, so this is for this X. When glucose reaction with H2 nickel, here H2 nickel means this is used to hydrogenation, that means reduction. Yes, sir, H2 is act as here reduction process in this case. Reduction, sir, when CHO H2 in presence of nickel is catalyzed here to form CH2OH. Then what you understand in this case? Aldehyde, when aldehyde undergoes reduction process to form alcohol. So here one alcohol extra is there. Already we have 5 alcohols are there, and extra is 1 OH. That means total 6 OH are there. So indirectly what you understand here, when glucose reaction with H2N to aldehyde is converted to alcohol. Again is reaction with H2O. So how many moles of H2O required here? 6 moles of H2O is required here. Total 4, 5, 6. So 4, 5, 6. Third option is correct one. Actually, what happens are when OH reaction with OH here, you know what? This bond will break here. This bond is going to be attack this carbon, and this oxygen is going to be hydrogen. So to form CH3 C double bond O plus CH3 C double bond OH here. So here acetic acid is eliminated. This bond is going to be attack this oxygen. So innately what you understand are here. So for example here, so C double bond O CH3, again C double bond O CH3, 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 C double bond O CH3. So this is the happen when reaction with the acetic anhydride, right? So third option is correct one. So I have covered only 15 questions. For next question I will make a video as possible as soon. Thank you. Please subscribe my channel.